Perhaps the most important part of computer processing is input data. Without it, programs will have nothing to process and there will be no meaningful output. A lot of our actions and decisions depend on information we receive from the computer. Hence, the very first processing step is in capturing the necessary input needed by the computer system. Data is generated almost anywhere and across any application area. Since computers are used most extensively by organizations, let us understand the sources of input data in this context. It is not difficult then to extrapolate the same context across any application area. The sources of input data in an organization can be of two kinds, internal or external. The sources of internal data are the people working within the organization who can generate input data by responding to program questions, entering inquiries, providing the facts that need to be processed. An example of the response kind of internal input data is seen when a banking clerk responds to the program query for an account number. Only when the account number is fed in does the computer generate the account details. An example of the inquiry kind of input data can be seen in the librarian asking about the availability of a particular book by the book name. And finally, factual input data comes from forms, visiting cards, letterheads, from which contact lists and details can be generated. External sources of input data are generated by people and groups that lie beyond the boundaries of the organization. They can be customers, clients, the government agencies, suppliers, and competitors. For example, you may call your neighborhood store to inquire about the availability of a certain brand of tea. Here, the store is a separate entity. You exist outside its working boundaries and hence become a source for external input data. Whatever be the source, there are many procedures and devices available to direct input data into the computer system. Data entry essentially involves capturing and coding the input data onto a computer-recognizable form. There are many possible data entry methods, and the selection of one over the other depends on two factors: the location where data is entered and the timing of the processing required. In most applications, data entry operations are scattered or distributed across the locations where the transactions actually occur. For example, the Air India airline booking system can handle concurrent bookings from many of its counters spread over a large geographical area. Or an organization captures the daily attendance details of all the personnel working in its scattered branch offices and factories. In such cases, source data automation and distributed data entry approaches are used. In other cases, a group of skilled operators located at a central computer site perform the task of data entry. For example, a group of skilled data entry personnel handle voluminous application form entries for university admissions at a central computer site. The time of processing is another important factor. In some situations, timing is critical because the input data has to be entered, processed, and the response required at the point where it is generated. These are situations of interactive or online processing tasks where the transaction data is immediately updated to a master database. For example, airline or train reservation booking counters, automatic teller machines, and point-of-sale terminals. These input data locations may be local or distributed. When the timing is not so critical, data at scattered locations may be gathered and stored for a period of time as transaction files on some form of storage media. All the data thus accumulated across the scattered locations are then periodically sent to a main computer site. This is where the data is updated into a centralized master file, processed, and reports generated. An example of this can be seen in franchise center operations like Domino's Pizza outlets. Here, The daily sales transactions are captured and then sent to the parent company on a monthly basis for centralized processing, which may include the calculation of royalty values, performance analysis, eating trends, etc. Centralized data groups are generally created to support large batch processing jobs. By now, you will be able to appreciate that although computer processing is very accurate, it is not infallible. The accuracy of predictable results depends on the accuracy with which the input data is entered and the accuracy in the logic of the program used to process the data. So, input data accuracy is one of the most important aspects of efficient computing. Erroneous input data arises in many ways. The source document may have incorrect information. The data entry operator may strike the wrong key. The data entry operator, in a moment of absent-mindedness, may switch facts between two entries or even switch characters within a single data item. Example, 7893 instead of 7389. It is important to catch these errors as early as possible, since the repercussions of wrongly processed data can be very expensive and strenuous on relationships. So, before sending any input data for processing, they are checked in terms of whether all transactions are identified and the transactions are accurately recorded at the right time. A few of the commonly used error detecting procedures include accounting for pre-numbered source documents, where a missing number in a sequential series detects a missing form; using control totals, where a computed total at the input stage is matched with the total after the process stage; using programmed test, where edit checks, range checks, and limit checks capture input errors at the entry stage itself. An example of edit check control is where the program ensures that the operator does not enter letters in a data area that can only contain numbers, example, rates and quantity, or a choice that does not appear in the list of fixed number of choices for a particular data field. Range checks are performed to ensure that numbers fall within a particular range, example, the number of days per month or a number of months per year or age groups, etc. Limit checks are performed to ensure that input rate does not cross the acceptable lower or upper limit values. Example, salary should not be greater than or less than the specified value. Most of these checks can be used at the point of data entry and hence reduce the chances for erroneous data being sent for processing. Having studied the sources and accuracy elements of input data, let us now learn about how input data is captured. The devices that are used at various points for capturing input data can be categorized into two types, depending on whether they are feeding online systems or offline systems. In online data entry systems, the input devices are directly connected to and under the control of the computer that will process the data. Online input devices share the following features. They enter the input data directly into the processor. They do not require immediate data recording. They may be located at or near the data source, which may be far away from the processor. They create a direct and interactive relationship between people and computers. They handle economically low and or irregular volume of input data. By far the most popular device used for online or offline processing is the Visual Display Terminal or VDT. The VDT comprises a keyboard used to enter the data and a video display unit or monitor used to display the keyed data and to receive messages and process information from the computer. The keyboard resembles a typewriter, although besides the regular typewriter keys, it has additional number and special function keys. The electrical contacts and circuits under each key translate the information directly to the computer. The main disadvantage of using keyboards is that the speed of data input is directly dependent on the typing speed of the operator. The VDT monitors generally use a cathode ray tube or CRT, which is very similar to the television picture tube. VDTs can be categorized as dumb, smart, and intelligent. Dumb VDTs are simple devices that immediately transmit each key data character to the processor. Smart VDTs are designed with a microprocessor chip circuitry capable of handling ALU and storage functions. Intelligent VDTs additionally have a built-in user programmable microprocessor capable of processing small jobs without the need to interact with a larger computer. Any input device, including the VDT, creates an interface between people and the computer. The interface is like a boundary that includes both software and hardware elements. The main goal for hardware and software designers is to ensure that this interface becomes easier and more comfortable to use. Since VDTs are most commonly used for data input, the monitor or screen and the keyboard components are being continually improved. Design enhancements that make keyboards easier and more comfortable to use are function keys, keys dedicated to specific functions to make keyboards more user-friendly. Numeric keypads, numeric keys arranged in one area of the keyboard, like those on a calculator, for rapid entry of numeric data. Detached keyboards, these are keyboards that operators can move to any desk or lap position. Features that make screens more pleasant to use are reverse video, screens with the background shaded with one color and the characters in a dark contrast for better visibility. Color, reverse video complemented with color displays for good visual effects and less instances of eye fatigue or blurred vision. Enhanced graphics capabilities. Graphic systems permit the display screen to be divided into thousands of picture elements known as pixels. Each pixel is controlled by the contents of a specific location in storage that is turned on or off to display an image. A screen capable of displaying a large number of pixels gives better resolution pictures and color effects. Touchscreens, where the screen has sensitive areas and the user can touch those sensitive areas for data input. Better product designs. These cover such aspects as tilt, swivel, flatness and size. Other input interfaces often used with VDT and PCs are the pointing devices. Pointing devices can be moved and controlled by the user's hand and have a corresponding pointing cursor on the screen that represents the device's movement. The device itself has buttons or keys to select screen objects. These include the mouse, joystick, trackball, light pen and input tablet. Pointing devices are generally used in graphics-based applications or interfaces. In many applications, the speed with which data needs to be input and processed is very fast. For example, at a supermarket, there may be a queue of customers with baskets full of purchases waiting for the billing process to be done. These application areas require the input data to be captured quickly at the point of sale. You may have noticed products bearing a symbol that is composed of thick and thin bars with a numeric code called a Universal Product Code or UPC. These are called barcodes with the necessary input data encoded within the bar lines and the numbers. The bars are decoded by a device called an Optical Character Reader or OCR. As the OCR scans the barcode, reflected light patterns are converted into electrical pulses and then sent to the recognition circuitry for comparison. If the comparison finds a match with patterns the reader is programmed to recognize, the data is then sent to the computer for storage or processing. Besides using optical readers, handheld wands attached to portable recording devices are also used. Most point-of-sale terminals can also read printed information in addition to reading barcodes. Financial transaction applications have different kinds of input devices. While the VDT may be used at the bank teller windows, some others are used in electronic funds transfer or EFT. One such EFT device is the automated teller machine or ATM. The ATM has revolutionized banking operations and funds transfer due to these features. It is an unattended machine. It may be located on or off the financial institution's premises. It receives and dispenses cash. It handles routine financial transactions. It works 24 hours a day. All ATMs need a card for identifying the user and verifying the account balance. These could be the magnetic strip cards or the latest smart cards. Smart cards are equipped with a chip to store information, thereby reducing the chances of fraud and abuse. Incidentally, the use of magnetic strip cards and smart cards can be widely seen as input systems in security areas for authorized access. Other EFT devices handle account verification and funds transfers. EFT stations are the checkout counters of hotels, hospitals, airline or rail terminals, and stores are used to check if a customer's check will be honored. Another EFT terminal is a touch-tone telephone, which lets you call a number and enter data by pressing the telephone buttons for funds transfer. The portable teleprinter is a handy device that allows the entry of data through a keyboard, then processes it and gives a printed output through a built-in printer. The compactness and versatility of use has made it popular amongst salesmen, managers, engineers, reporters, and other people who are generally on the move. Some other data entry terminals cannot provide printouts but display the output on a small flat screen. These are primarily data entry devices that may be able to transfer data into a processor but cannot receive data from a processor. Simple examples of this are the electronic order books used by salespeople on the move and the electronic diaries used by people for their personal use. So far, we've seen the use of input devices to capture characters and graphic codes. Some input devices allow the capture of human voice signals through a microphone or telephone. The signal patterns in this input are then transferred to the computer, where they are compared to a dictionary of voice patterns previously stored in the storage. When a close match is found, the word is recognized and the computer produces the required output. Most voice recognition systems were speaker-dependent. Recently, speaker-independent systems have been developed to recognize words that may be spoken by anyone. However, even the newer systems are limited to recognizing only a limited number of words spoken in a continuous stream. We have seen input devices that respond to touch by typing, screen touch or pointing, optical sensors, and sound. Some hardware firms have developed input systems that can actually respond to visual images. An input device that uses machine vision generally uses a TV camera to capture images and details, and a computer to compare the scan patterns with the stored images. These input systems are, however, used in very sophisticated and specialized applications such as in automated factories, RoboVision systems for component separation, checking the quality of assembled items as they pass an inspection point, other robotic vision systems used to recognize, grasp, insert and align various components needed to assemble some components. Areas that capture and compare the image of a fingerprint or hand for authorized access or identification of outlaws on the run. It is expected that automation in quality control and assembly processes will receive an impetus with the rapid development of robots with machine vision systems. Input data that does not need immediate processing can be kept aside for a period of time and then transferred to the location of the central computer for processing. Typically, these are data that are captured in an offline mode and used in batch processing. For many years, punch cards were used as storage media for input data. These required a card punch for punching patterns of holes as the input data on paper punch cards. A batch of cards would be punched and sorted into a sequence as a stack. Then, a card reader would read the information which was used by the master file for updating. Thereafter, the updated master would be carried to the central computer where they are processed. Around the same time that the punch cards were used, another media in use was the paper tape. Principally, it worked very much like the punch cards, but instead of having different cards, the media was a long strip of paper tape wound on a reel. The paper tape was punched through a paper tape punch and read via a paper tape reader. As the storage media technology changed to magnetic storage, hardware firms developed magnetic tapes to store input data. The device required in this case was the tape drive. The same tape drive could be used to store information as well as read from it. Even today, where high-speed and voluminous batch processing is required, the tape drive and tape has been the popular choice for input and storage. Before going any further, let us acquaint you with two terms in the computing jargon that will be used for data storage and retrieval. The task of storing data onto a media is called writing, and the task of retrieving information previously stored is called reading. The magnetic tape can be compared to the audio music tape used in sound recorders. Reading data from a tape into the processor doesn't erase the data in the tape, but writing to it changes the previous tape contents by overwriting on it. The tape unit may be a large reel or a small cartridge or cassette. The plastic ribbon wound in the tape reel is coated on one side with iron oxide or some other magnetizable material. Tiny invisible polarized spots representing data are recorded by electromagnetic pulses on the coated side of the tape, just as sound waves are converted to magnetic patterns on a music cassette. Magnetic tapes allow data and sound to be played back many times. They can also be erased and reused many times. The data density of the tapes is high and its transfer rate is fast. IBM developed a data entry system that allowed the source document data being keyed in to be directed onto a magnetic floppy disk. Commonly referred to as floppy, the floppy disk got its name from the fact that it was made up of flexible plastic material coated with an iron oxide recording substance that could be magnetized easily. The earlier floppy disks came in sizes of 8 inches in diameter. The 80s saw the maximum usage of floppies with a larger capacity but smaller size, 5¼ inches with a storage capacity of 1.2 MB. Today, you can see floppies that are even smaller and have a greater capacity, the 3½ inch floppies with a storage capacity of 1.44 MB. Like the tape drive, a floppy drive is used to write as well as read data. Here too, the data is represented as tiny invisible polarized spots on the magnetizable coating. Since floppies are removable and often transported to the area of the central computer for processing, all floppies are packaged in a protective square covering made of paper or plastic. A floppy disk is less expensive and can be reused many times. In the application of data input, a key to diskette area entry station records the input data directly onto the floppy disk. A small display screen guides the data entry person by showing the data being entered and allowing any modification to be made on it. Although floppies are used for capturing online input data, floppies have found greater use in being used as a secondary or backup storage media. Most data entry methods, particularly in voluminous and detailed jobs, involve data transcription. Transcription is the process of having a data entry operator transfer the printed data from forms and paper sources onto the input media. However, human resources or transcribers are not only expensive, they can lead to potential errors at the time of data entry. Character readers are the instruments used to read characters printed on the source document and then convert them directly into computer recognizable input. The use of such character readers eliminates the need to transcribe data into the computer. Some of the character readers used in high volume batch processing are magnetic ink character readers, optical mark readers, optical character readers. Magnetic ink character recognition, or MICR, is widely used by banks to process the large volumes of checks handled each day. In a check, you can see a special code along the bottom with the bank's identification number and depositor's account number. This MICR code, comprising numbers and other special symbols, are printed with a special ink that contains magnetizable particles of iron oxide. When these checks are entered in MICR reading units, they pass through a magnetic field which causes the particles in the ink to be magnetized. The reading heads are then able to interpret the magnetized characters. MICR data can be directly entered to the computer, or they can be transferred to a magnetic tape for later processing. The only limitation in the use of MICR data input is that MICR devices are designed only to read the 10 digits and 4 special character symbols required for banking purposes. The other kinds of character recognition devices that are used for data input perform optical mark recognition, or OMR. You may recall a reference to something similar when we discussed input data entry through barcodes. OMR involves recognition of characters or marks made in forms with pen or pencil. As the forms are passed under a light source, the pressure of a mark is detected by measuring the infrared light levels. OMR devices can be designed to recognize or ignore some colors so that marks on pre-printed forms are not captured as input data. One of the areas in which OMRs find maximum usage is in the correction of competitive examination papers with multiple choices. Examinees are allowed to mark the circle against any one of the answer choices. An optical mark reader is then used to capture the answers thus marked and interpret one's marks for immediate or later processing. Some optical scanners can also read certain handmade letters and numbers, but these characters need to be precisely written. Like OMRs, optical character readers, or OCRs, are also used for input data entry. They work on the principle of scanning characters, as though they were made up of a collection of tiny spots. Once the whole character is scanned, it is compared and matched against a library of previously stored character patterns. Some powerful OCRs can handle characters in different fonts and sizes. The scanner unit looks like a small drawing board with a rule that can slide up and down a rail along the length of the scanner. Reading heads in a small box are attached to the rule, which travels sideways over the line of characters above which the rule is positioned. In this manner, the whole page is scanned. Large printed manuals can be scanned and transposed into character form by OCR units. OCR devices have a wider application than MICR devices because OCR devices permit the reading of printed matter with no special ink and are not limited to reading only 14 characters or fixed size characters. This flexibility of use makes it possible for organizations in any application area to use the OCR technique and reduce the bottleneck during input transcription.